In this video, we're going to look at decomposing fractions before we actually go into integrating with the partial fraction decomposition skill. So this video is just to show you how to break fractions down. We're going to start with the fraction 1 over x squared minus 9. This denominator is a difference of two squares. You can factor that as x plus 3, x minus 3. Take each distinct linear factor, create two fractions with each one as the denominator, and we will figure out what numerators will make these two equal the original fraction. Multiply both sides by the least common denominator, which is x plus 3 times x minus 3. When you multiply by x squared minus 9 on both sides, that leaves you with a numerator 1. On the right side, multiplying by x squared minus 9, that will leave x minus 3 as the remaining factor times a. And then the second fraction, multiplying by x squared minus 9, after canceling, that leaves you with the factor x plus 3 times b. First, let's let x equal 3. Since we're solving for a and b, it would be nice to know what they're equal to individually. So we're going to be careful when we pick these. If we let x equal 3 in this statement or this equation, we get 1 equals a times 3 minus 3, which is 0, plus b times 3 plus 3, which is 6. The a group goes to 0. The b group at 6b. Divide both sides by 6. And we see that b is equal to 1/6. So we already have the numerator of that second fraction at the very top right of your screen. Now if we let x be negative 3, substituting into here, that's going to be 1 equals a times negative 3 minus 3, which is negative 6a, plus b times negative 3 plus 3, which is 0. The b group drops out. Divide both sides by negative 1/6. And we have a equals negative 1/6, which is the numerator of the first fraction. Now we have both numerators figured out, so this original fraction can be decomposed into these two simpler fractions. In the second example, we have a little bit more complicated fraction to investigate. Excuse me. We have x squared plus 36x plus 36 all over x cubed minus 4x. Factoring out an x, that leaves x squared minus 4. That's a difference of two squares. So this denominator completely factors as x times x plus 2 times x minus 2. This is a set of three distinct linear factors, so we'll create three distinct fractions with each factor as its denominator. That will give us numerators of a, b, and c to solve for. Multiplying both sides by the least common denominator in factored form, so that will give us the numerator x squared plus 36x plus 36 equals a times these other two denominators, because that single x will cancel. So it's a times x plus 2 times x minus 2. The middle fraction, the x plus 2 will cancel out. So that's b times x minus 2. B times x minus 2. And then finally, the third fraction, if you cancel out an x minus 2, it just leaves x times x plus 2. C times x plus 2. From here, we're going to be careful plugging in our values of x. If we start with 0, plugging 0 into this highlighted equation, we're going to get 36 equals 2 times negative 2, that's negative 4a. In the b group and the c group, because you have b times x, c times x, if x is 0, both of those groups go to 0. Dividing by negative 4, that tells us a equals negative 9. Now, if we let x be negative 2, plugging back into this highlighted equation, that's going to give us negative 32 equals a times 0 times negative 4. We'll multiply them by 0. Zero's out that group. B times negative 2 times negative 2 minus 2. That's a positive 8b. And then the C group, C times C times negative 2 times negative 2 plus 2, which is 0. Zero's this group out. So if you're careful substituting your number into the highlighted equation, you get the A group and the C group to zero out, and then that leaves negative 32 equals 8b, so B has to be negative 4. And then finally, we'll let x be positive 2. If x is positive 2, substitute it into your highlighted equation, gives you 112 equals a times 4 times 0, so that group goes to 0, plus b times 2 times 0, that group goes to 0, and then finally in your C group, C times 2 times 4, that's 8c, 112 divided by 8 is 14, so we now have all three of our numerators, negative 9, negative 4, and 14 respectively. So that's what you would have for these three individual fractions. In our third example, the power of the numerator outweighs the power of the denominator. So let's start this off with long division. We're going to take our denominator, that's the divisor, our numerator with the missing x squared term, that's our dividend. If you need to review long division, I reviewed in class, and I'm going to go over this example with you, but you might look into some college algebra textbooks. Basically, let's take the first term under the radical, divide it by the first term of the divisor. X cubed divided by x squared is x. X times all three terms of the divisor is x cubed plus x squared minus 2x. X cubed plus x squared minus 2x. Since we're subtracting these terms, we'll change all of their signs. Vertically, you have like terms. First column goes to 0. The second column is negative 1x squared. Third column is positive 1x. Bring your next term down, and then you start the process over. Negative x squared divided by positive x squared is negative 1. Negative 1 times all three terms gives us negative x squared minus x plus 2. Since we're subtracting, reverse all three signs. Vertically combine like terms. The first column goes to 0. The middle column goes to 2x, and the third column goes to 1. This big fraction is equal to quotient plus remainder over divisor. So that's x minus 1 plus 2x plus 1 over x squared plus x minus 2. This fraction, the denominator will factor as x plus 2 times x minus 1. That creates two distinct linear factors. So this fraction at the end can be broken down into simpler terms. We're going to create two separate fractions based on the factors of that denominator, x plus 2, x minus 1, and then multiplying both sides by the least common denominator gives you the numerator of 2x plus 1 we're going to solve for a and b. So multiplying by the least common denominator gives us 2x plus 1. A times the other factor, a times x minus 1. B times the other factor, b times x plus 2. Be careful here. You can zero out a group at a time by carefully picking x's. I'm going to let x be negative 2. Subbing into the highlighted equation, negative 2 will zero out your b's. So that leaves negative 3a equals negative 3, so a equals 1. Letting x equal positive 1 will zero out your a group. 3 equals 3b. And again, that's from substituting in the highlighted equation, replacing all the x's with a 1. Solving for b, you also get 1. So that fraction can be broken into 1 over x plus 2 plus 1 over x minus 1. Now, don't forget, we also had a quotient of x minus 1. So completely broken down, our fraction in the beginning is equal to x minus 1 plus our 2 decomposed fractions from above.